All right, Algebra 1. For today on transformations, we're going to just spend the day looking at Desmos here, and it's going to only take a couple minutes. So here we go. It's my cat in the background. Hey, cat, quiet. There's my dog chasing my cat. All right, guys, so y equals x squared. Looks like this red graph here. I'm going to keep this red graph here so you can see what happens. This is called the parent graph. So this is like the easiest graph that you could graph that is in the quadratics family. Okay, so what I want to do is show you guys, and I've done this already a little bit with you, but show you how modifying this moves this graph. So how do I modify the equation in order to move the graph to different positions? Okay, so the first thing, the big idea here is simply this, that if something happens on the inside of the function, and typically we use parentheses to show this, so if it's inside the function here, it's going to be happening to the x piece, okay, directly to the x piece. So we'd modify that x with some kind of parentheses. If something happens inside the function, then it will always be a horizontal movement. Okay, it'll either move the graph left or right, or it'll flip it left or right, something like that. Okay, if it is happening on the outside of the function, then we know that it's going to be a vertical movement. It's going to be moving it up, down, or flip it up and down. Okay, so let's take a look here what I mean by that. So let's look at the first one. So I'm just going to highlight some of these graphs. So I'm looking at number 2 here. Okay, it's the blue graph. It's y equals x minus 2 in parentheses squared. So take a look at this. Okay, from the parent function, notice I didn't modify the number in front of x squared at all. So it's going to be the exact same graph. The only difference is I subtracted 2 inside the function, inside the parentheses, and notice what that did. It moved it exactly 2 places to the right. And some people get confused by this because I put an x minus 2. They think it should be going to the negative, but no, it moves in whatever direction makes that x squared piece go back to 0. So notice that if you plugged a positive 2 in for x, that would go to 0, correct? So it's going to go in that direction, to the positive 2. Okay, so if I said x minus 3 squared here, you can imagine that that thing would move one more place to the right, right? Okay, so that's left and right movement if you just wanted to move it left and right. Let's take a peek now at the next one. So now notice this one is just, so the last one was x minus 2 squared. Now it's x squared minus 2, where the minus 2 is on the outside. Okay, and notice what that does. It shifts the whole thing down 2. Now, unlike the one where it's happening inside the function, this isn't about what makes this go to 0 anymore. If it happens on the outside, it's simply the y-intercept, right? So it's the y movement, but if it's negative 2, it's going to move down 2. If it's positive 2, it's going to move up 2. Okay, so that's how you can move the graph up and down. All right, let's look at another one here. This one is going to do 2 things. Notice number 4 on the left side here on my equations. I have something happening inside the function, and then I have something happening after that on the outside of the function. So just to see if you're paying attention here and to see how well you're getting this at this point, I would encourage you to pause the video and tell me where you think the vertex is for number 4. So where do you think the minimum point is for number 4? All right, so if I look at number 4 now, notice what it did. It moved over to the left 2, because that's what makes that parentheses go to 0, and then it moved down 5. Okay, so the vertex would be at negative 2, negative 5 on that particular case. All right, so that's number 4. Now what I want to show you guys is what happens when I modify that x squared term, and you've seen this a little bit already. So I want you to notice from the parent function, I'm keeping that red parent function there. Now I'm going to add a 2 in front of that. Okay, so if I put a 2 in front of that x squared term, notice what happens. The graph actually vertically, so this is happening outside the function because there's no parentheses, so it's happening outside. It's a vertical movement. So in the vertical direction, this graph is being stretched. Okay, we call that a stretch when it gets skinnier, and we call it a compression if it gets fatter. Notice this is when I have a number bigger than 1 there. It could also be a negative number that's bigger than 1 that'll also stretch, and it'll just flip over the axis. But let's look at what happens if I have 0.2. So let's look at, we'll keep that graph there, and then we'll look at 0.2. Here's 0.2. Okay, so 0.2, notice, got a lot fatter. This is called a vertical compression, where it's like something is pushing down on the graph and it's kind of compressing down and getting fatter. Okay, so that's 0.2. And what you're going to notice is anything between 0 and 1 makes the graph fatter. Anything between 1 and, infinity is going to make the graph skinnier. So that's kind of the rule there. Okay, and then number 7, look at number 7 here on the left side. It says y equals 3 times, and then in parentheses, so inside the function, we have a negative x squared. Okay, if it's happening inside the function, remember that it's going to be happening in the horizontal. So even though I don't like this because it looks like the exact same graph as 3x squared, what this is doing, if they ask you like what the transformation is for this one on your homework, this is going to be a horizontal transformation for number 7. Okay, but it looks so much like, just a regular graph that's just been vertically stretched. That's because it is, but it horizontally flipped. Okay, so when you plug in a positive number for x, you actually get the y value that's on the other side, and vice versa. Okay, so this is called a horizontal flip, and this is also called a horizontal stretch. Sorry, vertical stretch, because the 3 is on the outside of the parentheses. And then finally, number 8, we have negative 2x squared, where the negative 2 is on the outside of the function. There's no parentheses here. So this is going to be vertical. Okay, and since it's negative and vertical, what it's going to do is it's going to flip the whole graph upside down. Okay, so it's going to make it a little skinnier because you got the 2 out in front, and then it's going to flip it upside down because it happened outside of the function. There was no parentheses. So just to be clear here, if I graphed, so if you look at that number 7 again, notice it didn't flip it. Even though there's a negative sign there, it didn't flip it because it's inside parentheses, right? But if I take the parentheses away and put a negative on the outside, it will flip it. Okay, so if I said just negative x squared, notice that also flips it. Okay, let's see what happens if I said parentheses negative x squared. Notice what that does. That does not flip it. That keeps it the exact same. Okay, so that's an important thing. And the reason for this is the negative sign, when it's in parentheses, is being squared and turned positive. When it's outside of parentheses, it's not being squared, so the negative sign's added afterward. Okay, so that's a very important distinction. So again, if there's parentheses, this is a horizontal movement. So the transformation on this one, from my original, is simply a horizontal flip across the y-axis. Okay, so it's, even though it's the exact same picture, we still call it a horizontal flip because we have that negative sign in the parentheses. All right, guys. So this is just kind of a number of graphs that kind of walk you through what transformations do. I'm going to stop the video here and encourage you to fill out your 9.2. It's like a homework sheet, but it's also just kind of like a note sheet. And that's really what we're going to do for our notes for 9.2, and we'll do a couple homework problems together in class. See you guys next time.